I'm planning to talk about what's happened with Astropy in the last year. A lot of people are behind this. I'm just representing a very large crew of people that have been working on it. Here's a brief outline of what I'm covering. I'm actually going to say, particularly note, what I'm not going to spend a lot of time on this time is the background of why we're doing Astropy or the activity levels. I want to focus a lot more on what's actually happened as far as products and things added to the Astropy library and what's going on and what our plans are. So I'm going to start with we've had 2 releases, give or take a little bit, in the past year. 0.3 was released, and the major things in that included a new modeling framework and various things that, let's say, extended capabilities to use arrays, including quantities and coordinates, things like that. There was some table functionality that sort of gave it more database-like capabilities, and in general, there was a convolution subpackage added as well. The next release, which is almost out, it's always a little hard to say exactly when it hits the street. The release candidate is available, is 0.4. There's a lot of internal work. We're hoping that a lot of it doesn't affect most people. The things I'm going to note here are particularly there's a new SAMP package that's been added to it, and a lot of work in the coordinates package, a lot of work. And this has changed the API of coordinates. We believe it's going to be pretty stable after this, but there are some backward incompatible changes. There's a compatibility package that's provided to ease the transition, and it basically changes the focus of what the objects are. Rather than being objects that are essentially assigned to a certain coordinate class, they're general sky coordinates that can handle different frames of reference as options. At this point, I'd like to say something about what we see our users as being. To sort of oversimplify, I think there's sort of 2 general kinds of users. The first kind of users that maybe the kind of person you'd seen using IDL instead, who do a lot of their own tools. They expect to use a lot of low-level components to write their own applications, to do their own analysis and things like that. I think Astropy at this point is serving their needs pretty well, but there's also a second set of users that are those that don't do that kind of thing, that sort of would like to see higher level tools, applications, things like that. And those are users whose needs we need to meet as well. And for them, success is really not in the core package itself, but in the affiliated packages. That is, packages that we've sort of encouraged to use the Astropy core as the means of building all their tools on to ensure consistency between the different applications and libraries that are built around those things. And so I thought I'd spend a little more time this time around talking about these affiliated packages. We're not going to read through all these, but here you see a list of what we consider reasonably stable, and some of those in development. Hopefully by next year we're going to see a lot more, but I think in the past year we've seen a lot of progress in this area. And so I'm going to spend a little more time talking about a few of these. By the way, I'm going to go through some of these slides fairly quickly. They'll be available later if people want to actually look at details on these. So one of the things that has gotten work is AstroQuery. They're planning a release after the Astropy 0.4 release. They basically adapting to the new coordinates API. And starting to deal with caching and things like that, and adding new services. Another affiliate package that's seen a lot of activity is VoteYouTills. This is something that adds sort of source detection and photometry capabilities, and there's been quite a bit of activity. They have a Google Summer Code student working on it, and they're planning a release in August. And I think here there's sort of a hope that this may become part of the core as well. This is just an example image that they show of sources identified in an image, and I've added some of the lines below that are sort of key to what you'd have to do to identify those sources, the sort of the essence of the code to do that, and do some photometry on that. Another thing that's got a lot of recent activity is CCDproc. This is sort of akin to what's in IRAF. The 0.1 release is just out. I'm not quite sure what the status of that is. I think they're waiting for a Conda. Is it a?
It's on Conda and SciPy now. It does require.
Okay, it's out.
Yeah, it requires 0.4 RC1.
Okay, and so they're eager to get users to try it out so that they can come out with a 0.2 release quickly after that. Includes things like cosmic ray removal, clipping, combining stacks of images and things like that. So that's another very positive development. I thought I'd spend a little time talking about other things that have gone on Astropy. I mean, in just various areas. There's been improvements to the website. I'll just sort of give you a quick glance of the new website. It's not that new anymore, but actually there's still suggestions for improvement, so I think we're continuing to work on that. Other things include we've set up a framework for dealing with more serious changes to Astropy, and these are embodied in what probably a lot of Python people recognize. We call these Astropy proposals for enhancements, and that's where we do sort of discussions of really fairly big changes to how things work in Astropy. Coordinates is an example of that. Configuration is how we handle configurations and other. This again, it's mainly for dealing with things that need good documentation and justification for major changes. There's been a significant amount of activity in adding tutorials for Astropy as well, and so this is an important component for getting users to use it. We continue to see a lot of increase in contributors. I would say it's about double the number we had this time last year, and that's just in the core. But again, to sort of reference, I think where we'd like to see a big increase in the future is in affiliated projects, and that's where a lot of work would go. One of the things we're going to do in the near future is specifically lay out a list of projects that would be easy for people to get started on, both sort of at the beginner and intermediate level, both for core and affiliated projects, a sort of central place that they could go and see, oh yeah, they're looking for someone to do this. Does this match my interests? Does it match my expertise? And can I get a good start on this? And there are some things that are, I don't know if they're spin-offs, but they're related projects that sort of came out of Astropy in one way or another. WC Axes, which you may have heard talk by Tom yesterday. Airspeed Velocity, which is another talk about that came out of performance issues that we were seeing. And Eric Bray has come out with a schema for FITS files, which may be a very useful way of sort of classifying what the requirements are for a certain kind of data set, and that's been saved in FITS. So, I mean, all these are, some of these may appear in Astropy, but in any case, it's useful work that's been associated with it. I'm going to move on to a little bit about what the Space Telescope Science Institute is doing. Notably that JWST has targeted a fair amount of funding to deal with data analysis. And this is a non-negligible effort. I mean, we're talking about several FTEs over a number of years to build data analysis tools. Now, understandably, they're interested in filling JWST needs, but I've been very careful to tell them that these tools have to be general and not very targeted to JWST needs, that they need to be generic tools. If you want people to use these tools, they can't be just good for one telescope. And for the most part, most of this work we intend to go into Astropy or an affiliated package someplace. This is where we would like to put our data analysis tools that we develop out of this. Opportunities like this don't come along often, where you get a significant amount of funding for data analysis. So I hope we use this wisely. So I'll talk about some of the kinds of work that I think still needed to go into the core. One of them is to sort of finish the modeling framework, and this includes a number of things. To make it more useful, this has come out of our trying to use it, so as we do these things, we see what the limitations are and what we have to do to make it more useful. So adding metadata to models, it's not required, but it makes doing other things easier. Specifying a default sampling set. This is useful for doing things like integration over models. Support for arithmetic and other kinds of binary operators, so that you can construct new models simply by writing an expression of existing models. And that has potential of being very powerful. We may, and things that some people typically want to put into models, I think we will probably try to separate into separate functions rather than part of the modeling class. As an example, an integrator. It makes sense, I think, to make these a little more generic, that they work with models and other things, and they don't necessarily have to be methods in a lot of cases. And again, we would like to integrate the quantities better with Astropy in general, models and tables and things like that. WCS is a big area that hasn't been finished. I seek WCS, more generalized WCS package, and by that I'm not talking about what's in FITS, but a system that lets you specify WCS in a very flexible way. Is being developed now. Other things that are being worked on, faster table I/O. Tom Allcroft has a Google Summer of Code student working on that. We're also looking at alternate formats of FITS. This gives some people the willies, but we need something like this to save some data that FITS is just very bad at dealing with, and in this particular case, dealing with generalized WCS is a big driver for that. We're in the process of adding a spherical geometry package. This lets you do things like footprints on the sky, compute intersections, unions of areas, and things like that in a way that has no dependencies on particular coordinate systems, like it has no polar issues, for example. We would like to do a lot of improvements to the FITS package. They're waiting for these other things to be done, but and finally figuring out, I don't think the details are worked out, but figuring out how to deal with errors and uncertainties in a more general way. We're also looking at application-focused development. Things that are more useful for the end user. For example, we've sort of have a imexamine tool that equivalent to that in IRAF. I'm just showing a brief screenshot. You can go in. This works with DS9, but Erik has just made this functionality work with Ginga as well, where you can sort of interact with the image and do things like get plots, cross plots, radial plots, print out values around where the cursor position is, things like that. So source identification extraction, some of this is work that's actually being with VoteYouTills. Dealing with a more generic drizzle tool, making Python vote capability available. These are just sort of short-term things. We have many other longer-term things that we have in mind. As it was been mentioned, we've been working with Glue, and You saw some of that demoed with what Erik was doing with Ginga. I just sort of we've added some spectral cube viewing capabilities to it. But the original aspect of GLUE, and I'll just highlight this briefly, was the ability to sort of display data in a variety of forms, and you could select a region in one of these representations and see what the corresponding selections are in the other views. And so it's basically a linked view thing for which you can see what parts of one view show up in another. But it's being extended for other capabilities now as well. So one last slide is on future releases. One of these Astropy proposals for enhancement talked about what should our release strategy be. And basically, the goal is a 6-month cycle. Adhering to it exactly is not an easy thing. We'll have bug fix releases more frequently. The next release after 0.4 is intended to be 1.0. That's our goal. And there's also a goal of having long-term support releases designated every 2 years, so that you could see that we will tag these as long-term support releases. And what we mean by that, if there are important bug fixes and things like that, we'll continue to make it to that release. You don't have to upgrade everything else in order to get some of these maintenance issues taken care of in that. So that's the end of my slides. I thought I'd just say, for those that are interested in contributing to Astropy, we're going to have sprints on Astropy during the sprint period of the conference. And if there are people that also would like to just talk generally about priorities, goals, needs, whatever, please contact me or Tom or one of the Astropy people and see if we can arrange something, especially if there's a small group that would like to talk about that. At that point, I'm ready to turn it over for questions.